Ladies and gentlemen, our program will now begin. Please welcome the CEO of Churchill Club, Karen Tucker.
Thank you. Thanks, everyone. Welcome. It's great to see everybody. Appreciate you coming out for this. Tonight, we explore location-based services and real-time location systems, the role they will play, the opportunities going forward that they represent. And with us to weigh in are Mark Johnson from Descartes Labs, Vilat, oh, go ahead. Vilat Keomoungkhoun from IndoorAtlas, Vinay Shet from Lyft, Bersabel Tadesse from Mapbox, and to guide them in conversation is one of the best around, Kevin Collins from Accenture. Some of you asked about speaker changes, so wanted to mention that here. Mapbox CEO Eric Gunderson was unable to participate, and he hand-selected Bersabel to take his place tonight. We appreciate you being here. And Luke Vincent from Lyft had an urgent out-of-town meeting, and Vinay is here to carry that baton, so thank you very much. A huge thanks to our partner, Accenture, without whom this gathering would not be possible. We really appreciate it, especially Julie Rosendahl, Kevin Collins, and Matthew Quinlan for their invaluable assistance. Thank you. And thank you also to Mapbox, especially Leslie Nakajima, our partner in this as well, for help and support. We appreciate it very much. Just a few words about Churchill Club for those who are less familiar. We have proudly served for over 30 years as a business and technology thought leadership platform to explore opportunities for innovation, economic growth, and societal benefit. We think of ourselves as forward-leaning because we're looking to identify implications of the trends that are occurring today, and that's what we try to accomplish from the stage. We always ask our speakers never to pitch or promote or position, but really come thinking of themselves as in a position to advance collective knowledge. If you are not already following us, we invite you to do so on our mailing list on Facebook, LinkedIn, and the hashtag for tonight is simply Churchill Club. Without any further comments here, I think let's get our panel started. Welcome, Kevin and our panelists.
Thanks, Karen. Please. Which side are you sitting?
Oh, you.
I'm going to be right here.
I think this is right.
Yeah, I think it's right. I think we'll be okay.
More or less.
Do we do it? Did we get it right?
Perfect.
Yeah.
Oh.
Okay. First of all, thanks to all of you for coming out and spending the evening with us. Thanks to the panel, who you'll hear in a second have very busy day jobs. And as always, thanks to Karen and the Churchill Club. They make this stuff look easy, but now having had a chance to peek behind the scenes on a couple of these, it's not easy. It's really hard to put these things together. There's a lot of not just logistics, but really pulling together a theme and kind of nailing it down, and these guys do a great job. So thanks to you for all that. Okay, there's a formula for these kind of panels, right? You get two incumbents, you get one disruptor, you put them on the stage, and you ask questions kind of right at the point where their strategies diverge or conflict. And then you just sit back, and we all learn a little bit about the shape of the industry as they kind of battle it out, right? This is not that panel. These folks are somewhat partners, somewhat adjacencies, and in a lot of cases you can make an argument that they're just not in the same space at all. But what they share, is that they are at the forefront of what's happening in location and geospatial and this space. And they have front row seats to some really, really interesting things. And so what we are going to attempt to do in this kind of non-formula panel is we are going to try to give you both a broad brush of what's happening across a range of use cases and also dig into a few of them. Okay, so we're going to talk about everything from building mapping layers to AI to analytics to bringing services literally to your front door, and in Vilat's case, through your front door and into the house. So without any further ado, what I'd like to do is just take a minute to let the panelists introduce themselves, learn a little bit about them and their companies, and then we'll get started. Bersabel?
Sure. I'm Bersabel. I'm Director of Product for Navigation at Mapbox. Mapbox is a location services platform for developers. So we make APIs and SDKs that allow developers to integrate maps, search, and navigation into their mobile, web, and embedded navigation or applications. Sorry.
Hi, I'm Mark Johnson. I'm CEO and co-founder of Descartes Labs. We are a Santa Fe, New Mexico-based startup, and our focus is on building a geospatial data refinery. So it's effectively a platform that pulls in multiple sources of satellite data, and we use this to better understand what's going on the planet. Our specialty is looking at commodity traders and looking at supply and demand factors for them. But effectively, we have eyes in the sky that are trying to better understand the planet we live on.
My name is Vilat Keomoungkhoun. I'm at IndoorAtlas, where I do stuff. Been there since they came out of stealth. The company provides indoor positioning technology that's based on the Earth's magnetic field. So I'm here representing the unexplored great indoors.
Hello everyone, my name is Vinay, Shet. I'm a director of product at Lyft, focusing on their mapping efforts. Lyft, as you know, is the fastest growing ride-sharing network in the United States. Today our service covers about 95% of the US population. A little bit about myself, at Lyft I've been focusing quite a bit on something called ETA and locations, and we'll know what those terminology means as we go, as the evening progresses. Prior to and of course, recently I've been focusing a lot more on mapping for autonomous vehicles as well. Prior to Lyft, I was working at Google. I was the product lead for the Google Maps data and the navigation data. And my team was one of the teams that built out the machine learning-based analysis of street view and aerial imagery to actually build maps data at scale. So look forward to a live conversation today.
Great, yeah, thank you all. So format, we're going to spend about 45 or 50 minutes going through a few areas that we've set up, and then we will leave plenty of time for your questions. It's always kind of my favorite part of these sessions because we get really interesting questions. There's always a wide variety of experience in the audience, so I look forward to that. As a starting point, if we could, let's sort of get a common view of what it all takes. So what are the big rocks? What are the big technologies? What are the big pieces that need to be in place in order for me to navigate my way to work or find the nearest Starbucks or watch the polar ice caps melt? What needs to be in place? Anyone want to give us a starting point?
I can maybe take a stab at the data.
Please.
So there's different pieces, obviously. If you look at the data, the maps data piece of it, I would say there are 4 major areas. And the terminology might vary across the different companies, but I think it's more or less matches. At the very bottom of this, in fact, this is like a layer cake. So at the very bottom of this, you can look at it as things like politicals. You're talking about the country boundaries, state boundaries, county boundaries, zip codes, and so on and so forth. A level up, for lack of a better term, orientation. This is when you look at a map, you want to understand which way is north, which way is what. And these are things like lakes and water bodies and your rivers and so on and so forth, parks. A level up is where it gets interesting. This is where the actual road network lives. This is the actual road geometry. This is what kind of road is it? Is it a freeway? Is it a side road? Is it a paved road? Is it a dirt road? All of the attributes of that road. What is the speed limit and so on and so forth. And a level beyond that on top is all of the points of interest. These are things like your businesses. These are things like what is called Geo Codes in the industry. A Geo Code is basically an address string, 1, 2, 3 Main Street. What is the exact lat long of that address? So that's a Geo Code. So all of that stuff is on the point of addresses side. And going a level deeper in that, also all the attributes of those points of interest. At what hours is a business open and when does it close and so on and so forth. So that's roughly the data stack. And I don't know if you guys have a different perspective on this.
Yeah, I think the way that I think about it is in sort of 3 buckets in terms of how we actually make the data. So one is data that we make, and so this is latitude, longitude, timestamp, and elevation, right? So we collect that, aggregate that at scale, and not just know where there's a road, but actually know the directionality of the road and the speed, right? The other sort of bucket would be data we buy, right? So this is things like imagery, satellite imagery, aerial imagery. You can use it as is or sort of use it to make more data, right? And then sort of the social places like bars, restaurants, things like that. And the other one is data that we crowdsource, right? So this is things using sort of open data sets, right? This is things like Wikidata, Wikipedia, open address databases, OpenStreetMaps, right? Basically using data that's coming from ground truth, from local sort of contributors that we're able to aggregate and then also build onto this sort of layer cake that Vinay mentioned.
Yeah, I mean, I'm interested in this idea of ground truth. Who owns this stuff? And is there one, or is there many? And I guess the kind of the side question is that the right way? Is the way it is today the right way? Should somebody own this whole thing? Or do we want a heterogeneous environment? And kind of what's the pros and cons of that?
I mean, there's two major types of data, as you said. There's sort of this unstructured sensor data. These are the eyes and ears of the computer that are picking up what's going on in the world. And then there's call it ground truth, which is sort of our human semantics put on top of that. So this can be a lot of different things. It could be that this is a road, it's a one-way road, but it could also be there's a field here, and last year it was corn, and it produced 183.3 bushels of corn. And those ground truth sets are varied because people care about different types of semantics depending on where it is. And so we do a lot of work in agriculture, which is why I think about corn. And across the industry, for example, everybody has enough data to go build models, to go test out your models, to go train your models, but everybody is sort of like sitting on pockets of it. So I think that this collection of ground truth and who owns that ground truth is going to be one of the great challenges of AI the next decade.
Can I?
Please.
Going back to the first question, I think these guys didn't mention the fact that they've got something that's free, GPS, Global Positioning System. Defense Department put it up, $12 billion, and they keep it running $700 million a year. Indoors, GPS doesn't work. So our problem is getting that GPS-like technology indoors. So that's what we need for indoors.
So the places that the data comes from are different. The way that it's processed is different. All that is different.
Well, GPS just doesn't work indoors.
Yeah, so you have to come up with a whole different set, beacons and whatever else.
Yeah.
But everybody has a cell phone indoors.
Right. Yeah.
And outdoors.
But the cell phone, I think it doesn't work when you don't have a line of sight to satellites for GPS. So that's where.
I'm pretty sure Android has your location at all times, though, right? I mean, I think there was just a story about this the other day, right? I think this is actually what's interesting is that these same sensors deployed in different places. If it's in a home, you care about a certain set of things. If that cell phone is in a car that's allowing it to navigate through the twisty streets of San Francisco, that's another thing. Or if there's a bunch of cell phones in a mall and that's an indication of purchasing, that's another thing. So it's like these same sensors can be used in many, many different ways. And I think that's one of the great things about these sets of data is that it's not indoor versus outdoor, it's not cell phones versus satellites. It's really an amalgamation of all these types of data that's going to give you the kinds of models you want.
Yeah, that's where what IndoorAtlas does is we provide a technology that's based on the sensors. It's sensor fusion. Yes, we take advantage of all the sensors that are available, and we all look at the Wi-Fi and beacons. But the foundational layer is what is the anomalies caused by the presence of metal in buildings. So that's what we use to provide GPS-like positioning indoors.
So am I getting this right? There's some sources of base truth. There's some satellite information. There's some maybe government-owned information. There's a bunch of base stuff. But it sounds to me like what you're all saying is that there's a lot of interesting things happening on how you layer information on top of that. And really, is that where you see the value evolving? I mean, is base layer boring now? And now we're moving into interesting stuff above it?
Depends on what you mean by base layer.
Right.
Yeah. Again,
mean,
yeah.
So it's layers all the way down, and then there's varying levels of semantics as you go up. I mean, you probably know about this better than any of us, right?
Yeah, I mean, I think it depends on how you define that base layer, but I think sort of every layer is always going to be important, right? I think what you mentioned is really interesting in that the data that you can sort of layer on top makes it vastly interesting for specific use cases, right? I think when you think about a company like Snap, for example, they're able to not just use sort of the base map, quote unquote base map, they're able to take their data that's specific to their business, how they operate as a business, layer that and integrate that into that map, right? And sort of increase engagement, increase revenue. That's when things become interesting. But I don't think you can sort of make certain layers sort of go away or make them more boring. You sort of need every layer to make it work, right?
So the story, though, if I hear you right, is going to be people are going to all have their own data sets. They're all going to be creating their own stuff, whether it be from origination, like going out and figuring it out themselves, or analytics, however they do it. And everybody's going to be using it in a kind of heterogeneous environment, kind of tied to some position. Is that basically the model?
So I think I do want to differentiate between the unstructured data and the structured data piece of it. I think the unstructured data is what we were talking about earlier with the satellite imagery or street level imagery and so on and so forth. To some extent, even the raw GPS locations I would use to some extent unstructured. The structured piece on top is the semantics. It's like the road network, or it's the building geometry footprint, it's the location of a business, and so on and so forth. Right? Typically, the unstructured data is what leads you to create the structured data on top, and that can be application specific. Like one industry that cares about one specific thing might focus on one aspect of structured data, while somebody else might care about something else.
Got it. Where do you see most of the innovation happening? I mean, is it one area or another? Is there some huge hurdles that are still out there and other places where we've seen massive progress? What do you see as the places that are ahead and behind in doing this work?
To me, infrastructure is incredibly important, and it's not sexy. Like no VC wants to hear, well, I'm an infrastructure company. I'm building a data refiner, building a platform. That's, they want to know what sort of algorithm you're using and what sort of fancy things you're building on top of it. But in order to enable that kind of machine intelligence on top of this data, you have to mass a huge, huge amount of it. The Earth is very big, at 150 million square kilometers of land mass, and you want decades of that imagery. So just in our case, we have over 10 petabytes of data in the archive. We pull in 15 terabytes of new data every day. And that number is just going to ramp up as more satellites go up. So I think just taking, and we're only dealing with satellite data. I mean, there's tons of other sorts of location data we could be looking at. So just the sheer mass of the data is almost currently untenable.
Yeah, I think that's right. I think it's sort of scale and speed, right? It's like you need data everywhere, right? And location data is inherently localized, right? So it's very different across the world. You need to collect that data, and then you need to update it in almost real time. The world changes all the time, right?
Yeah, so how do you do that? And so there's two things I wanted to ask about from what you just said. The first one is, do you really need the whole world? Like, it seems like there's some applications where maybe you don't need the whole world. Can you be a local player? Can you just have a certain country or a certain region and actually pull that off for some apps? And the second question you brought up, which is, how the heck do you do that? I mean, the second that you're done, you're out of date, right? So what are the methods that you see out there for people to keep that up?
Yeah, I mean, to your first question, I think yes, but it depends on the use case, right?
Okay.
I mean, you have certain companies that only operate in North America, where sort of a map in North America makes sense today. But if they're thinking about growth, are they thinking about international growth? Then a North American map today will not make sense tomorrow.
Yeah.
And so it absolutely depends on the use case. I think if you're someone that's trying to target a very specific industry, a very specific market, then no, you don't need to think about scale in that way. But that's not going to always be true, because companies need to grow. And you're not, and for a player like Mapbox, we're not sort of serving consumers. We're a platform for developers. We need to be thinking about that scale. We need to be thinking about sort of international markets and sort of internationalization.
So you have to be everywhere.
Yeah.
I think another way of looking at that question you just asked me was that most data tends to be long tail, in the sense that if you look at the world from the perspective of impressions that it gets, like in the case of Lyft, a small amount of geography ends up resulting in a large number of rides. And so being able to focus on that small amount of geography gets us the most bang for the buck. So when you normalize it not with respect to the flat geography, but when you normalize it with respect to the number of rides that you're getting or number of impressions, depending on your industry, you can prioritize your efforts there and focus on those parts of the world.
I mean, I think one of the challenges with location data, so I used to live in San Francisco, and then I moved to Santa Fe. And Santa Fe is one of the largest towns in New Mexico at 70,000 people, which suddenly means you don't have as many Yelp reviews on things, you don't have as many cell phones, you don't have as much cell phone service. So I think that there's sort of a glut of data here, and there's a lot of places where that just isn't the case. You can't sort of take what happens in a big city like San Francisco or New York for granted everywhere else because there's a lot of productive areas where you just don't have the same volume of data coming through.
And when you get outside the U.S., it gets worse.
Yeah, it gets worse.
When you get to certain markets, yeah, you read about that all the time. Vilat, interesting for IndoorAtlas, right? You're starting without a ground truth, right? You kind of have to
Got nothing.
Yeah, you gotta have to make it all up as you go along, right? So how do you do that? And that seems hard.
It's a big challenge. Like Mark was saying, infrastructure is boring. So we need the GPS of indoors to start with. Otherwise, there's no innovation that could happen. Anything that these guys do outdoors needs to happen indoors. For example, if somebody calls Lyft and pick me up on the street level, take me to SFO, what happens when I get to SFO? I go in there and I get lost. So the wayfinding, the rerouting as you find problems on the road, that needs to happen indoors as well. Mm-hmm. So, and the analytics that you guys do, it's required indoors also.
Yeah, I mean, so that there's a whole separate set of challenges that
Yes.
we're gonna have to kind of get into to figure out how to do that. In this world of heterogeneous layers, are we starting to see the value, the money, just to be coarse about it, right, start to flow to certain pieces? I mean, how is the value chain kind of hashing out?
Satellite imagery has been dealing with this, and so satellite imagery was the province of the US and Russian governments for most of its life, and then in the 90s was unleashed. The US government said, okay, you can put up some satellites. And Digital Globe is sort of the big satellite company. They've been taking pictures of the Earth for, well, since the 90s. And I was thinking, like, when we first started Descartes Labs, it's like if you were the CEO of a Fortune 500 company, and I told you there were spy satellites taking pictures of an opaque economy like China every day, I'd say sign me up. But if you look at their revenue, most of it still comes from the government. So I think satellites, for example, have been struggling with this for basically its entire existence as a commercial industry, in that governments are best equipped to deal with that data. And only recently has commercial satellite imagery been something that people start to use and find value in. And I think the factors there are just, again, the data is super, super big. So you need supercomputing level storage and computation to do anything useful with it. And machine intelligence has just come so far along in the past, I mean, certainly the past decade, but even the past 5 years, that now it's possible to start extracting value at scale from those complex images.
So the analytics then become kind of one of the places where value accrues.
Yeah.
Yes.
I think another aspect also is that if you look at the structured data stack, right, I think satellite imagery in the last several years has become plentifully available. And so I think if you look at the structured data set, the base levels of that, things like road geometry stuff, that you can directly extract from satellite imagery is probably comparable across a lot of the major map data providers across the world. Right? Where it becomes harder to compare them is when you need to extract features that are only visible at the street level, for which you need street level imagery. Right? Think of it like a U-turn sign or U-turn prohibited sign, for instance. That you cannot see from space. Right? And the only way you can see it is if you have a picture of that sign taken from the street. Right? So although you have machine learning algorithms in play to analyze imagery, if you don't have the imagery in the first place at that resolution, it's not possible to extract that. The other aspect also is time. Further up in the layers, as you go into the businesses, the POI is part of it. They change very frequently. I believe restaurants or POI in businesses in the United States churn at about 10 to 20% per year. That's a lot. Right? So even if you did have street level imagery, it would still not be up to date by the time you come around next time, after a year, right? So I think those are some of the challenges where if you can crack that problem on top, there's a lot of value to be unlocked there. And I think the lower levels of structured data are ones that I would almost say that they're comparable across different providers.
Extend that indoors, and you've got more problems.
So I think when a lot of us think about this problem, we tend to think about consumer apps, right? We think about Lyft, right? We think about Yelp. We think about a map on my phone, right? What are you all seeing in terms of non-consumer applications? Because it feels like every time we have an innovation like this, we talk about the consumer stuff, but actually there's tons and tons of value in industrial and government and all these other areas that most of us walking around aren't thinking about. What are some of the big things that you see coming outside of consumer apps?
So we work, again, a lot in commodity supply chains, and again, lot of not sexy stuff here sometimes, but like we all eat, and it turns out that food, it doesn't just come from Whole Foods, you have to grow it somewhere. We all like our iPhone, and it turns out you don't, like those don't come out of the ground, you have to mine a bunch of things and build plastics and all sorts of things. So watching those is really valuable. There's trillions of dollars in those markets. And I think what's interesting about the companies that play there is that they weren't fundamentally disrupted by the internet, by mobile, by the PC in the same way that, for example, media was disrupted, where that entire industry got digitized and now you deliver movies over the internet instead of via DVD or VHS or something like that. But now with sensors being deployed everywhere, suddenly their world is lighting up. So they don't quite live in the digital realm, but they at least have, call it a digital twin of what they do. They have a digital twin of their supply chains. And oh, by the way, not only can they see what's happening in their own supply chain, but their competitors are going to be able to see what they do, and they're going to be able to see what their competitors do. So I think that this will fundamentally change how companies that extract, refine, and move around core commodities operate in the world because of the kinds of data that we're all creating.
Are you seeing that play out now?
Yeah, for sure. So, for example, one of our partners and one of our investors is Cargill. So, one of the oldest companies in the U.S., one of the largest companies in the U.S., and their focus is in agriculture, especially their history is in grain trading. So, they own a network of grain elevators, and it means they care about things like how much grain is growing around an elevator. So yeah, we've done a lot of work with companies sort of in a much more traditional space, even though. You know, we came out of Los Alamos and do fancy machine intelligence. Really, our core customer set is folks moving around physical commodities.
Are all the companies in this space kind of required to create their own ability to drive machine learning, their own ability to do the AI? Is that something you can go outside and get? Are there centers to do that, or is it something you just have to own? One of the things I'm interested in, just to kind of put it to the point, is I'm really interested in what you need to own versus what you rent and how you think about that problem.
But do you mind if I just address your previous question before we go to this on the consumer side?
Yeah, please.
I do think, I don't know if you guys agree with this or not, but I feel like the future of mapping and maps data is not in the consumer space. Rather, it's in the non-consumer space. The reason I say that is because you mentioned Lyft as an example of a consumer app. But if Lyft's ambition long-term is to be able to actually replace car ownership, right? So as a user of Lyft, you don't need the map. You just tell us where you want to go, and we'll get you there, right? So you don't need to look at your phone to see your route. I don't care what the traffic is on the route. I just need to get to that location. And in the future, where autonomous vehicles, are all around us, maps are really maps for robots, not for people, right? So it's really maps are being consumed by a machine, not so much by humans.
I think there's.
Go ahead.
Sorry.
Go ahead.
I think you're right, but I think you're going to see sort of bifurcation. You're going to have sort of two different types of maps, right? So you're going to have navigation maps that aren't going to be used by humans. They're going to be for sort of robots, but you're still going to need, you're going to see sort of maps for people that are more about not how to get where you're going, but sort of about the place that you're going to.
Discovery.
Right,
Place
exactly.
discovery.
It's maps for
Exactly.
discovery. That's sort of like where maps for people are going. And
That's
I think if you think about sort of, again, going back to Snapchat, it's like a perfect example of this, right? It's a map that shows you, that allows you to discover things around you, right? And I think it's a map that's sort of a user interface to the world, right? And I think that's sort of like where maps for people are going, right?
So yeah, I mean, kind of AR always comes up as one of the first things, and kind of my view of it was my first AR experience was driving down the road with a map in my lap, trying to figure out where we were going, right, as a kid. So you hear a lot about that, but is it truly that one of the spaces where tons and tons of innovation, and is that pushing the industry?
I think location is absolutely critical for AR. And I think it's sort of burgeoning right now, but I think when you're going to actually see it is when you get to a place where you have sort of AR glasses that are ubiquitous, right? And you have AR glasses that are sort of serving as the new browser, right? To sort of like to AR. And when you're there, you're going to have people wearing these glasses that sort of look around the world and they expect to see content, right? About everything that they're seeing. And it's, well, how do you place that context? You need context, you need a reference system, right? Latitude, longitude. You need the location, you need the map to actually place things in AR. And that's absolutely critical.
Those
Can
aren't
we go
AR
back
glasses, right, Matt?
3 questions?
What's that?
Can we go back 3 questions?
Please.
Because we find, IndoorAtlas, we find basic stuff sexy. So you talk about
we get excited about this stuff
and we have a client in Florida that use our technology for indoor wayfinding. So the sponsor of this program, the project said he used to spend hours upon hours a week telling new staff how to find their way to offices and whatnot. After implementing this project, he said an hour max of wasting his time telling new employees. So for us, that's innovation, and it's sexy because it saves him a lot of time. People just have to open up their app. It will guide them from wherever they're standing to radiology department, for example, or to the cafeteria, or wherever they want to go. So that's the non-consumer app that we have. That's today is live.
Probably also emergency services, all kinds of stuff would fit in there, right?
Yeah. Yes. But they also have different requirements on the location data that you might want to use, right? For example, AR, I think as an application, it's obviously, there's a huge potential there. But the kind of location data you need to make AR work is not the usual location that we talk about. You actually need something called 6 degrees of freedom there. You need that long elevation and pitch, yaw, and roll of the camera, so know exactly where you're pointed, so you can put the virtual creatures in the world, right? And I think that's a much more much more deeper kind of location than what most of us here are talking about right now, I think.
So is it harder or the same as autonomous driving?
I would say they're two different things.
So both hard.
Both hard.
So then are either one of them, in your opinion, sort of driving the innovation in the industry? One of the things that I'm interested in is what are the things that are focusing people's attention to push to the next boundary?
Like AR, for example, I don't think is driving location-based services, right? Like, to me, location-based service are going to be an enabling technology for AR, much like mobile computing is, much like the internet is, and that AR will become much richer and more interesting because of location-based services. I think that location-based services are being driven by the fact that people care where stuff is. They care where humans are, they care where they're going, they care where their iron shipment is going. And people will always care about location. So I think it is sort of a core enabling technology of sort of the next generation of how we digitize our world. It's sort of digitizing the world out there and bringing it to your mobile device, bringing it to your enterprise resource planning system, like whatever it is, sort of better understanding what's going on out there is a core technology.
I somewhat disagree. I think that in order to make like AR work, you have to have a hyper-precise location, more so than we have right now. Right? GPS is extremely messy. And I think in order to sort of like reach that pinnacle of AR, like there is innovation happening to make sure that we can have clean GPS data, that we can make the most of it, so that we can place, so you don't have drift with AR, and you can accurately place things. I mean, this is true for autonomous as well, right? Yeah. Precision is absolutely key, and that's where sort of the innovation is being driven.
That's true. I mean, you're absolutely right. It's sort of the edges, like it's forcing a kind of precision that, like you said, it doesn't, if I'm a few feet away with my cell phone, I mean, Google Maps will figure it out, but if you're playing with your Pokemon, then it's not as
But I meant, my point earlier was that the autonomous and AR are a bit different in that I think the difficulty arises from different aspects of the technology stack. With AR, I mean, AR has been around for a long time, technically speaking, right? But it was bad AR, right? I mean, what you need to really crack AR is that hyper-precise localization. If you have that, we have an AR solution today. Right? With autonomous, you have a different sensor suite that lets you get the localization that you need. But then the problem there is something else. You want to be able to actually see the objects properly. You want to be able to react to what's happening in the world. So it's a different aspect of complexity that comes into play there.
So with that, I mean, obviously it's been in the news a lot lately, right? What do you think the role of government is in this stuff? And I'm sorry to drop a stinky egg on the ground, but what's the role of government in all this? If I'm a senator, how do I think about this problem, and how should they, in your opinions, how should they wade into this, and sort of where should they play guardrail role, or just hands off?
Specifically, or?
Yeah. Is there a role? Maybe there's not. I mean, is there a role?
So I think you said it earlier. So the U.S. government funded GPS, and now we all appreciate those services because we all have cell phones. NASA was very prescient and put up the first Landsat satellite in the Landsat program in 1972. So we have consistent monthly images of the entire globe thanks to, almost 8, one failed, but 8 different satellites that have gone up. The European Space Agency has put up a series of creepily named Sentinel satellites. But this is really important, right? That if you want to better understand what we're doing to the planet, it's really important that like as a treasure of humanity, we have these pictures of the globe over long periods of time. We're doing climatological studies. We're trying to understand how many trees have been cut down. So, especially in the early days of these technologies, they're very expensive, and sometimes the government's the only place where you have enough money to go collect that kind of data. So I'd like to see the government get, and this is weird for me to say being a libertarian, but they ought to be more involved in some of this core tech and collecting data.
I agree with you wholeheartedly. Because imagine the day when you make this 911 call from here, and then with that call arrives at the call center, Vilat's calling from the Marriott, second floor, in this room. And if the government were to enable the technology indoors, that's possible. That would save a lot of lives.
Yeah, well, so we're not going to get off the stage without talking about privacy. So we'll get there in a minute. But that's one kind of area that obviously government's going to have a role in. I think this is another one that's interesting, right? So how much of this should they be funding, collecting? Should they be the source of truth for some of this stuff for us? And is that even possible, right? Because not known for keeping things up to date.
In the world of agriculture, the US government does really, really good job of predicting how much corn is being grown in the US or soy is being grown in the US. We spend a bunch of money doing it. And we also have government agencies that have huge amounts of ground truth data. So how much per field was growing. This data would be incredibly valuable at this point to the agricultural industry as a whole to better understand where it fits at global scale. And even after multiple FOIA attempts, they still keep that data secret. And like one of the functions of government could actually be keeping a gold standard set of ground truths for various things that we care about.
I mean, I think if there's one thing we can take away at the end of this panel, I want to make sure that we all agree on is that mapping really depends on what is the end application that you're servicing. Lyft cares a lot about the road network and traffic and all those kinds of things because that's core to our business. We don't care about the crop yields.
You don't care about corn in Iowa?
We don't
Just not hitting it.
And he doesn't
not
care about
driving into the
yours?
field. Yeah.
right? And so I think it's very application specific. And so I think I think we're going to see as time goes by that a lot of these companies that drive the core applications are going to define what cut of that structured data that they really care about and then chase that down. So in that world, I'm sure government might have a role to play in some of these applications like 911, for example. But beyond that, really, I think the company should be able to define what they focus on and what they really want to dig deep into.
Okay. Sort of a little bit of a left turn. For 10 years, and especially for the last 5, we've been hearing about journey to cloud, over and over and over again, right? We've talked about it. Lots of people have talked about it. Now I'm hearing more and more about, hey, for a lot of our applications, particularly in this space, I've got to do stuff at the edge. Like I can't kind of wait for the cloud, or I can't push things back and forth. How are you guys thinking about the evolution of the stack and where processing should be and how that all happens?
Well,
nobody. It's okay. Anybody got a sense of that?
I think you're absolutely right. I think it's definitely moving to do more sort of computing on the edge, and I think you're definitely seeing a push to better chips to enable this. I think data transfer takes some time. It can be expensive, even as you sort of get to a world where there's sort of like 5G. It's more efficient to do on device, right? And I think sort of that's definitely where sort of the industry is growing. And I think as you think about like the types of data you want to transfer back and the types of data you don't want to transfer back, you can sort of process and collect more diversity of data if you do more sort of on the edge as opposed to sending data back.
Yeah, I mean,
right?
It seems like we're sort of bifurcating what we're doing. Because remember, just a really different example, but do you remember when they started out with Quicket and they were like, well, here's what we're going to do, right? You're going to keep all your information locally, and we're going to put the application out on the cloud, and then that way your stuff is safe on your computer, and then you can get the updates and stuff from the cloud. And then eventually they switched it, and they were like, well, wait a minute, that's not right. Your stuff is safer on the cloud, and we want to actually process the thing at home. And now it's sort of halfway in between. It just feels to me like we haven't quite figured out what's the best stuff to do centrally and what's the best stuff to do locally.
Well, I mean, there has to be you have to do something to make the data smaller. So your eyes pull in a petapixel of information a year. I certainly don't store a petapixel of information in my brain. I store all sorts of abstractions about the world around me. And it's much more efficient for this very efficient cognitive device sitting here to do that. A plane taking off from JFK and going to Tokyo generates a petabyte of information about diagnostics and engine information. Most of that is useless, right? And you don't want to have, with thousands of flights every day, literally exabytes of data produced by planes. Most of that's not useful. So you really have to have at least some computation on the edge, both for while you're on the plane, the diagnostics, and then what do you save for later? So I think we almost have to, just out of necessity. Bandwidth is not increasing with Moore's law like chips are, right? Like 5G is going to finally be around and it's faster than 4G, but that's the best you've got wireless. And then even transferring data, the fastest way to get a petabyte of data from your servers to Amazon is via FedEx still. So until that changes, you're going to have to do at least some processing on the edge.
It's called SneakerNet, right?
SneakerNet's still around. It'll never die. I know. Anything else on that one? We kind of move on. Okay. All right. Let's just, in the interest of time, let's just dive into privacy here. So, look, you can't touch this topic without touching privacy, right? You had the Strava thing, accidentally mapping military bases recently. You had the literally crazy freak out about snap maps. I don't know if you guys saw that. People went bananas about snap maps and knowing where everybody is all the time. And then, Mr. Zuckerberg in Washington, everybody's very sensitive on privacy right now. How do you think about privacy in this space? Vilat, indoor and looking at things, and then the better and better and closer and centimeter level precision. And how do I think about the trade-off of privacy versus functionality of the services for me? How do you decide?
We're a European company, I think Finland. So the GDPR
yeah.
is comes into effect May 25th, so in about 4 or 5 weeks. So we comply with that regulation, but I think privacy, it's you want privacy until you need for people to know where you are. Emergency case, I go back to that. If I make a call, I need people to attend to me because I'm going to die if somebody comes to me. I want people to know, right?
Yeah.
So, but on the other hand, people say, oh, I don't want people to know where I am. So, but we, as a company, we comply with the requirements of the law that's coming into effect, and that's how we are able to operate in multiple markets around the world.
So there's compliance.
Yes.
Okay, that's a standard. And then there's sort of beyond compliance. Like how are you all thinking about it? I mean, obviously you're facing it every day, all of you, right? How do you think about this problem? What are the dimensions you're using, and how do you keep from irritating all your users?
I think you have to optimize for privacy first, and you can't sort of compromise you can't sort of compromise privacy in order to collect more data. If you think about sort of like building a map, and sort of this is sort of the stance we take, right? Like latitude, longitude, timestamp elevation, and nothing else. We don't want anything else, right?
Okay.
And so you can build a road network, you can build a map with all of that data without having sort of like the personal information. Obviously, there are interesting applications by collecting more different types of data. Sort of going back to the point about like what do you do on device versus what do you do on the cloud, and what do you send back, right? If you can do sort of more processing on the edge, you can sort of use that data locally, then throw it out, and then you send back things that are actually not personal, right?
But as we get further and further down the path, we're going to just keep pushing on that thing and keep pushing on it, right? And there's always some player in the chain that could reconstruct it, right? I mean, I think that's the fear that you always read about and hear about, right? Is that somewhere along the line, whether it's the carrier, the handset manufacturer, or the app owner, or somebody can reconstruct it back to, hey, that was me, right? So, what do you think?
The app owner can always make the link. We don't, because we don't keep any PII. So we just get the request sensor data that is sent to us, and then we send the estimate back, and we don't know anything about the user.
You know, this concept of PII, I mean, I go back to, I think it was 2003, AOL released a data set. It was a bunch of search queries. And this was for, scientists to go mine and whatnot. One of the first things people did was like, oh, I bet we could tell who did these search queries. And very quickly they were able to take a large percentage of the search queries and point it back to a person. So I think that, privacy has has been eroding for quite some time. Well, I don't have my cell phone in my pocket, but we all mostly have cell phones on us at all times. We give permission to all sorts of applications to make our lives better. I want Google Maps to know where I am, otherwise it won't tell me how to get to where I'm going. So the reality is that our phones are picking up massive amounts of data about us. There's massive amounts of data out there being used to make all the apps we use better. And I don't know how you put that genie back in the bottle. Like, we can try to be smart about it. We can try to, like you said, like, think about designing privacy first. But our concept of privacy is going to have to change in the modern technology world.
So the ship has sailed, and individuals can make individual decisions to block things out and get worse feature sets. But as a society, we're living in a non-private society. Get over it.
I mean, I don't want to get.
I mean, right?
I mean, like, I don't think it's a good idea, like, for us to deploy cameras in everybody's house and, like, you know, have feeds of everyone. That would be a bad
That's not
idea.
how you do it, Vilat.
No.
But the reality is that, like, we're voluntarily giving up a lot of information about ourselves to free services who then collect that information and make that free service better. And I just don't see that changing. I mean, do you really want Netflix not to collect movie watching information so that my recommendations are awesome? No, of course I want my recommendations to be awesome. So yeah, I think it's one of those things that we're just going to a challenge we're going to have to accept as a society, that you know, our relationship to privacy has changed. What privacy means has changed. And yes, we probably need some smart regulation to make sure that we don't completely give up our privacy, but our relation to it has fundamentally been altered.
I think what you said is really interesting, like, collect the data to make the service better. So it's not just about the type of data you collect, but it's how you use that data, right? And so if you're actually using the data to actually make the service better, then there's a reason to collect that data, right? There's sort of like a reason why I would want someone to have my data. But if it's sort of, I don't think we're ever going to get to the point where we're sort of just giving away our data for whatever use case. That's just never going to make sense.
Some of it's choice, though, right? If I get the choice to make that trade, that's one thing. If I don't get the choice to make that trade, that's a different question.
Sure. So you give users, you know, the ability to opt out, for example.
You don't look like you're buying it, Matt.
We always have the Equifax problem, right? Like, fine, so service collects a bunch of data on people to make the service better, and they don't use the data for anything else, but then there's a security breach and a bunch of data is out there. So again, like, there's data about me all over, and I'm not sure that there's any way to take all that data and put it back in a bottle and, you know, keep it in my private safe at home.
Paper,
I wish there were, but
paper. We're all going
paper.
back to paper.
I mean, yeah, Battlestar Galactica. That's what it told us. We don't want the aliens will attack us if we use the internet.
Okay, I want to make sure that we have.
Joke.
I want to make sure that we have time for these guys to ask questions. But so sort of furthest binoculars on now. If we get this right, like, if it all comes together and we get the privacy right and we get the sources right and we invest in the right things and we build it out right, what does the world look like, right? And then the converse, right? If we get it wrong and we clamp down on privacy too hard, or, you know, entities misbehave or something happens wrong, what does that look like? And how do we? I want to think about the golden case and the really bad case so that we can think about our options from here. Does it make sense?
Yeah, I think one aspect, you know, when you say get it right, what does get it right even mean? In my point of view, especially with the structured maps data, the piece that we need to absolutely get right is data accuracy. It needs to be correct. When the map tells you this is a one-way street, it better be a one-way street.
Right.
And so I think if we're able to nail that down, that we get the data absolutely accurate, then I think it simply unlocks a whole slew of high-level applications that depend on maps data. Right? We talked about AR, we talked about autonomous vehicles, right? And, you know, government, there's a lot of applications out there that can depend on this stuff, where it all hinges quite a lot on making sure that the accuracy of the data is there.
Okay, so if we get it right, we have current and accurate data.
That's right.
Okay, that's one good part. What else?
So for me, when I'm 75 years old, my eyesight's failing, and I call Lyft. Hey, pick me up, drop me off at SFO. I'm taking a flight from gate 68. So what I want is Lyft to pick me up, drop me off, and then using my app, because I can't see very well, it tells me, hey, you go through TSA check-in counter, go through here, and then I say, hey, I want to go restroom. I want this application to guide me to the restroom, to men's restroom, not women's, and then get me to the gate. So that is what I hope to
Sort of persistent with you, follows
yes,
you around,
one
seamless,
application
place
all the way
to
through.
place.
So I think at the crux of this is sort of efficiency, right? I think if you sort of nail everything, if you get the accurate data, you're going to make everything sort of more efficient, right? Sort of location is sort of at the center of so many different industries, and if we get it right, this is why we're sort of going towards autonomous, right? We're trying to drive towards efficiency.
Yeah.
If we get it right, we sort of optimize for that. I think if we sort of get it wrong, it sort of depends on how you define get it wrong. Maybe we make missteps with regulation or sort of privacy, safety, what have you. I think all that does is just delay that inevitable future, right? This is sort of a future that we're driving towards eventually. And so it's just a matter of when and not if, right?
Bunch of optimists. Okay, good.
Yeah, I mean, I just thought I'd pile on there that, like, absolutely it's all about efficiency. Like, I imagine a world, again, back to corn, like, where it's a very sexy topic, that where the corn is grown in the fields, it's picked up automatically by combines. There's a truck that shows up to your field that takes you to a grain elevator. Machines decide the best place to go deploy that corn, whether it's to a feedlot or to a place that makes ethanol. And that entire supply chain is way more efficient because instead of just having localized operators that are doing the best they can with the information they have, there's both localized information and global network information, and that world will be way, way, way more efficient.
That sounds actually pretty good. Okay, I want to make sure that everybody has time because it's a big topic. We covered a ton of stuff and we only scratched the surface. So I want to make sure that folks have a chance to dig in a little bit. So if you have a question, please raise your hand. Someone will come around with a mic and you can ask the panel.
Thanks, everyone. I have a follow-up question on the infrastructure space that you guys mentioned, right? So how much would you all consider the infrastructure for processing and collecting this data as a core business proposition, or this is something that you are willing to give it to someone else and pay? And if so, why are you not doing it already? What is missing?
I guess either of us could answer that.
Yeah.
Go.
Sure. I think, yeah, absolutely it has to be core, right? I think sort of going back to Vinay's point, sort of what makes the data sort of the most efficient is the accuracy of it, right? It's being able to sort of not just collect the data, process the data and update it at sort of like near real time, right? The world's constantly changing. And so you have to absolutely sort of own that problem to sort of solve the accuracy problem to then get to the sort of efficiency future.
And when we look at it is it's also about sensor fusion. So no single sensor is going to solve all of your problems. It's often taking data from very different sensors who see the world in different ways. So imagine one that's a radar that penetrates the clouds but can't see in the same way that humans do, and another is optical, and you combine those two and you get a much richer model. So yeah, you do have to have all the data, and I can't imagine outsourcing that. Like our role in the industry is to try to be that collector of all the data where analytics can happen. So I think you're going to see more companies like ours. I use the metaphor data refinery because I kind of like that, and it speaks to corn and oil. But I think you're seeing many more companies like ours who take this model of pulling in lots of disparate types of data, clean it up, make it analytics ready, and you'll see tons of applications sort of growing and sprouting up on top of that.
Next question.
Hi, my name is Roger Royce. I run a group called Silicon Valley Ag Tech, and I have a question for Mark mostly, but really for all of you. There are proposals to legislate farm data in particular, both on a federal level and on a state level, and right now we've got, I guess, self-regulatory initiatives out there. So from people that are out in the field, pardon the pun, is industry doing a good enough job with protecting data, setting standards for ownership, privacy, and security, or do you think there's a need for governmental regulation?
I don't see this as a problem in ag. Farmers are notoriously hold their data close to their chest. They don't like, farmers are, they sell to the major grain traders and see themselves having an adversarial relationship. They don't want a data imbalance where the grain traders know more than they do, so they get worried about that. They're very private about it. Sometimes they'll lie to each other. So you don't see the same problems in ag, for example, as you see with Facebook, where everything is just shared. Now, this is going to change. Again, combines drive themselves now, right? Like the thing that you used to drive through the field and picks up the corn, those are almost completely automatic now. So they have hundreds of sensors on them that are looking at soil moisture and nitrogen content and all sorts of things. So I think it might become a problem over the next decade as we automate more processes in agriculture. But I think for now, there's no necessity there.
Hi, my name is Bill. I work at a startup called RideOS, and we are accelerating the future of transportation. I have a question around returning the data back to the source where the data comes from the community. So whether it's GPS from mobile probes, whether it's imagery from AR, indoor information a lot of it comes from people, individuals, autonomous vehicles, and so on. And we build these services and data models and derivatives from the source data. But we've seen some kind of great products built out of community-based data, like OpenStreetMap. So my question to you is, are you thinking about how we can take that data that comes from consumers or autonomous vehicles and things like that, and returning it back to the community to help society and other technologies build?
Yeah, absolutely. I can speak to that. I think you mentioned OpenStreetMap. Obviously, Mapbox is a huge sort of supporter of OpenStreetMap. And if you think about back to the sort of the layers that I talked about, right? One of those layers is crowdsourcing and being able to get data from a community, but then also provide that data back, right? And I think you're never going to have one or the other in terms of just proprietary or just open, right? There's a place for both. And I think when you have things that are open, it lowers the overall cost of ownership, right? And I think for certain layers, for certain use cases, it absolutely makes sense. I think for others, it might not make sense. Where maybe it makes sense to keep it proprietary. Maybe it's sort of too specialized, where it actually doesn't make sense to have a community around it, where you're putting it back in the open. But I definitely think there's sort of a place for it in sort of like the layers.
Anybody else?
Hi, my name's Craig. I'm from Gap, and my question's primarily for Vilat. Besides wayfinding in, besides wayfinding in very large spaces like medical centers and airports, what else do you see as the most interesting applications of internal location services?
So we've got a deployment in Thailand where they've provided an application for, they call it a guide for indoor-outdoor marketplace, a weekend market. So that's one instance. We have also seen somebody deploy the technology at casinos in Macau. Also, inside corporate headquarters, for example, when you're making a reservation of a meeting room, and at this point, let's say you invited 10 people. 2 of those people turn up late, 10, 15 minutes. You've wasted everybody's time by 10, 15 minutes. So what these companies are doing is that they are providing wayfinding, indoor location wayfinding as part of this application. And if you invite me to a meeting, then I can find out where I am, and then I know where to go, and it gives you wayfinding. So efficiency is being created there, and a lot of savings are being achieved.
Boy, the casinos are going to be really irritated by that.
What they want to know, some casinos, what they want to know is if you're a big whale that you're playing, your family's with you. If they see that your family is moving out at lunchtime, they want to incentivize you to go to a steakhouse, so that they don't leave and take you with them. That's an example.
Yeah. So they'll do the usual. They'll give some away and they'll take some back.
Yes.
More than they give. Yeah. What else? Anyone else? Please.
So my name's Cyril. I'm with Drive AI down in Mountain View. So the question that I have is, how do you guys see the industry evolving in the short to medium term with regards to a couple different things? One is I would say the high precision, maybe like localization-based data and mapping versus the coarser mapping that maybe is semantically more interesting, like the lane networks and things like that. Do you guys see the industry bifurcating over time, or do you think there's going to be a certain intersection and a certain synergy there?
I actually think these two are very tightly coupled together because the higher level maps are talking about in terms of the lane network and all the stuff that autonomous vehicles need to really use. It is of no use if it floats in space. It has to be bound, stapled very tightly to the location of the physical world, much more tightly than just just a coarse lat long. Right? So the next time a car comes back to that location, it should know exactly what lane it's at and what are the features around it. So I'm not sure if I necessarily see a bifurcation. What I do, what I think is not clear to me right now is, are we going to continue to live in a world where hyper-detailed maps of autonomous will continue to be built out the way they're being built out today, or rather, are we going to start moving intelligence more and more onto the car? So you have a sparse map data, but the car is smart enough to perceive the world in real time and then act on it. Right? That's interesting. Chris?
So, building infrastructure management and digital twinning, I heard you say before. Building infrastructure, I think my voice is louder off the microphone, but building infrastructure management and digital twinning. You said something about that before. So that seems like the end goal, and yet that's a technology that exists, albeit one that's probably pretty expensive to use. But how would that impact each of you? And is that data that you'd use or data that you'd look at when you're trying to understand both context?
Is digital twinning here?
Well, building infrastructure management is, yeah. People are taking actual understanding, digital twinning buildings and infrastructure that exists right now. It's an Autodesk tool. There's many other companies that own products that do that right now, that companies like Microsoft and others are investing globally in, right, to be able to maintain, understand, operate, and geolocate different things within their infrastructure around the world.
I mean, sure, but we're still in the very early days of that. Like, that's an example of how to do that in buildings, but there's large swaths of this world that are not covered. Again, Iowa being a great example of this, where there's large fields and not as many people in Iowa. So there's all sorts of places where those digital twins don't exist yet. Complex supply chains don't have digital twins. Product supply chains don't have digital twins. So I think one of the themes that's come up over and over here is that there's lots of data out there, and really it's the context you want to use it in. And building the infrastructure with an end context in mind is really important, because you'll likely come up with different infrastructure, different analytics on top of it, and probably different data sources that go into it. So I still think we're at the very, very early stages of both deploying sensors and collecting their data, and in building, call them digital twins of the planet, or whatever you want to make a twin of.
I meant, is it something you want to leverage? Is it?
I mean, we built a lot of custom infrastructure because no one's ever gone and analyzed petabytes of satellite imagery at scale, right? Like, so you kind of have to build a lot of custom stuff. This used to be done on supercomputers, and now we have the cloud where you can spin up a supercomputer. So yeah, I think a lot of those technologies are sort of the old era, and you'll have a whole new era of sort of widely distributed sensors and all that data coming into some central repository. So those old tools I don't think are going to be that useful.
The new tool, building infrastructure management, brand new. But
Okay. That sounds like an offline. We got time for another one or two, yeah?
Question about differences in geographical content, geospatial content across the globe. So you have countries like China, which have more government control over the use of that content. Countries in like India, where maybe the quality or fidelity or addressing system is less sophisticated. What impact do you think those differences will have on the development of businesses that rely on geospatial content, like ride sharing?
Yeah, so I think mapping in I would say in the Western world versus in developing markets is actually a fairly different problem. Like if you look at emerging markets like India, like they don't even have structured addresses, right? So like, how do you pinpoint a specific location? So that has a whole slew of different challenges comes along with that. So. So Lyft right now is focusing primarily on the United States market. And so this is not yet a problem that we have to encounter, but I would imagine that any company that operates in that space is going to have to address the problem head on, else they're basically going to be lost.
Yeah, I think this is an inherent problem with location. It's not just sort of country to country. I think it's sort of, there's sort of differences across even cities, right? And I think what that means is it changes sort of the type of data that you need to collect, how you, the type of data you store, and then how you present that data. I think India is a really interesting example where you have a different sort of addressing system, and a lot of navigation happens by referencing POIs, and so that's sort of like what you call out, right? That sort of is different in other parts of the world, right? So that again, that impacts the type of data you collect, how you store that data, and then the data you present. But this is just, it's sort of an inherent problem across location, across markets, across geographies.
Anything else anyone wants to ask? Please. Can we get him a mic? Thank you.
Hi, my name is Jagdish. The question is there a value for enterprises to get the slice of the data back in-house, which they can use for further improving their products or their services and so forth? So for example, if you're using a mapping technology to do the data, the lat-long data stays with the mapping provider. It doesn't come back into the enterprise. So is there a value there?
Go ahead.
I mean, I think it really depends on the application and sort of what type of data that you want to actually bring back. Yeah, I think it really depends on the use case. I mean, if you're talking about like just lat longs, how would you use those lat longs, right? How does that sort of like move your business forward? Are there other sort of like things you want to store? Like maybe it's important to store the road network. This is happening today, right? There are certain applications where you want to sort of use the data that's provided by a provider, and then for whatever reason you want to sort of store it on your servers, you want to use it locally. Like this is happening today. So it really depends on the type of data and then the application and like how you sort of want to use the data that you store to sort of move your business forward.
I agree with that. I think it definitely depends on the application. From Lyft's perspective, for example, in an ideal world, I would rather have some other company worry about the whole map stack, and I focus only on the applications on top that are really aligned to my business goals. But really, there are three things that will come into play that might change that calculus. The first thing is basically accuracy. I keep coming back to that topic. If the data is not accurate, everything downstream is in trouble. The second thing is rights. Like, can I really build a product on top that is unencumbered, unburdened, and I can actually truly unlock my product features? And the third thing is cost. Again, in a cost-competitive business like ours, we cannot pay an arm and a leg to license maps data. So these three variables really help us decide whether we want to bring some of the data back, or do we just partner and work with somebody else.
In terms of accuracy, indoors we can give you 2 to 3 meters. But in terms of the value to the enterprise, if you own a mall and if you knew if you could generate a heat map of where people go, you might be able to change the rate or the rent, for example. So,
yeah, I mean, people are paying huge amounts of money for trying to back into that information now, so that's great. Okay, I think we're about short on time, right?
Thank you so much, Bersabel, Mark, Vilat, Vinay, for sharing your perspectives so freely. We really appreciate it, and Kevin for leading the conversation so well. We would like to present you right now with the Churchill Club speaker T-shirt.
Thank you. Thank you. Very exciting. Thank you. A recording of this program will be available on our YouTube channel within the next, say, 24 to 48 hours max. And there you'll find other recordings of our programs. We hope that you find it in general to be a very useful resource. Our next scheduled program is in May. It is our 20th annual Top 10 Tech Trends. I believe it's the 22nd. We may be slotting another one in there about quantum computing on the 15th, which would be up here in San Francisco at the W. So keep an eye on us. Hope you'll join us for our upcoming programs. You've been a wonderful audience. Thank you so much. See you next time. Good night.